Awesome. So welcome to NYC.rb. Yeah, all right. Sorry for the last minute location change. We had some scheduling conflicts in our usual space, but Daniel from Shopkeep was really generous and offered up the space and beer and wine. So can we get a hand for him? All right. We have two really great talks about GraphQL and chaos from two of our engineers at Exo Group and a giant saw above. But I think Daniel has a few words for us before we get started, so I'm going to hand it off to him.
Hopefully WeWork, who's upstairs doing massive construction, is not going to disturb us too much through the meetup. We'll see. Yeah. So welcome to Shopkeep. Shopkeep makes a point-of-sale tablet to cloud for small businesses, focusing on small businesses. But that's not what I'm here to talk about. What I'm here to talk about is hosting meetups and the community in New York City and in the world as technologists. We are part of that community. We learn from each other, and it's important that we give back. And so that's one of the reasons why Shopkeep hosts meetups, speaks at meetups, talks at every opportunity that we can, whether it be at a conference, commits back to open source software, or releases open source software. And I implore every one of you, as a guest at a meetup, please look for your own way to do your part to give back to the broader tech community, because it's really important. That's how we all grow as an industry. That's how we grow as individuals. So thanks for attending. And if you can come to my meetup, Continuous Delivery NYC. You might have seen cycle through. Anyway, thanks for coming.
Hey, everybody. Hi. Hey. I'm Brendan Kemp. I'm working with Brian and Spencer. And yeah, I'm a consultant with Exo Group right now. But at my previous job, I implemented GraphQL. We were implementing a new mobile app and with a React front end, and we implemented Apollo for the front end, and then we wrote the back end in Ruby because we had a legacy Ruby app that we were moving on from. And I felt like it was a really pretty easy experience. And my general sense of the state of knowledge of GraphQL, and maybe I can get a raise of hands to confirm or deny this, is that like people know generally about GraphQL, but may not have used it in their professional jobs yet. Thumbs up, yeah. So my thought was for this talk was to just kind of walk you through an example app of implementing a GraphQL server in Ruby using GraphQL Ruby. Because like, I don't know about you, but I learn like conceptual things a lot better when I see like a practical implementation in something that I'm familiar with, like Ruby. Like hopefully a lot of people here are familiar with Ruby. So my hope is that I can show you a little bit about like how you can just pretty easily add a GraphQL API alongside like a legacy app or a REST API. How it hopefully you'll see how it's pretty easy and it offers advantages for API development, and yeah, just like the real practical nuts and bolts of how you get things set up. Because at least when I was looking for this, I didn't see a ton of blog posts about like specifically how to implement something in GraphQL Ruby, and also they just went through a big API change where they went from like a magic like factory bot style API to the class-based API. So a lot of the stuff is out of date. So anyway, that's what I'm hoping you'll learn. So let's get started. So first thing that I want to do is introduce GraphQL in case people haven't like heard about the concept. It's thrown around a lot, but hopefully I can do a little refresher. So I mean, GraphQL is just a spec for defining APIs, and making client API calls. It's not specific to any connection. Like you could run it over smoke signals or anything. Like you don't have to run it over HTTP at all. It all sits at the application level. And so that makes it different from REST. Like there aren't multiple endpoints. It's not something that exists within HTTP. So you only create one endpoint, which is kind of nice, but you end up making other endpoint-like things, as we'll see. It's strongly typed, which is really cool, and that allows introspection into automatically into every API you create. So you can click into the documentation automatically for every API you create. And conceptually, it's just it's a graph of entities. So the nodes are your models, and the edges are the associations between your models. And then you send queries against that graph that you created. So that's a lot of like high-level abstract stuff. So let's try and get down to the nuts and bolts of it. So this is a really basic GraphQL query. This actually works. GitHub was one of the early adopters of GraphQL, and they have an open API and a sandbox that you can play with, and it's really awesome. I really encourage everybody to take a look at that. But I mean, here is everything you need in a curl. You just need your authorization, and then you send a little bit of plain text, basically, and GraphQL's job is to parse this and then return to you JSON in the same format that you asked for it in. So to expand the query part of that, of what we just saw, this is the same thing, but it's a little easier to read. And so this is a query, and you format it the way that you want the JSON back. And if you send this to GitHub, then they'll send you back JSON in the exact same format, but with all the values filled in. So here the viewer object is user. Oh, the user who's logged in. And in that case, that was me. And you can query as many individual attributes on that object as you want. And you can leave any off that you don't want. So this is one of the first great things about GraphQL is you pick exactly the data you want. And if later a feature changes and you need to add more information to your view, you just add an additional field and it'll be sent back for you. Okay, so hello? Oh, we're back. Okay, so that is just like a really quick overview of how GraphQL works. And so let's take a look at how we set it up within Ruby, because you can set up a GraphQL server in basically any language. There are implementations for so many languages now. And the way that Ruby does it is very Ruby-ish. So here's the example we'll be taking a look at. I built a little example app for this talk. It's your typical to-dos and to-do lists. So what we have here is a query, and we want to get the to-do lists for the logged in user and get the title of the to-do list, and then get the to-dos associated with the list, and just get the name and a Boolean relating to whether or not it was completed. And when we send that query, this is what the response will look like. So it's a JSON formatted in the same way that we sent the query. And we have a grocery list with only milk and cookies because we're developers. And so in order to walk you through like all the different moving parts and help visualize and conceptualize the whole flow of information, I found like there were a lot of moving parts. So I made a little, I guess this is like a an entity whatever graph. But so here, we'll be able to see like all the different parts, and I'll break down each of these. So the request comes in the upper left. Can everybody see? Okay. Okay. So the request comes in, and then that is handled by your GraphQL controller, and it has an action on it called execute, just like any other any other Rails controller. And then that's the GraphQL's queries entry point into the GraphQL engine. So the execute call passes that into the schema, which we'll see, and then that schema passes it off to a specific query that handles, it's basically the endpoint, and then the different entities within your application, whatever your business domain is, you represent with different types. And then it'll go and it'll fetch all that information, and each one of those types tells it how to serialize into JSON, and then that feeds the information back to the controller, and then the controller gives back the JSON response. So we'll break down the different parts of this here. So this is like just a visualization of one query and the different parts that it's going to touch in the data flow. Okay, so first let's start with what we're familiar with, the controller. So we take a look. This is just a regular controller action. It's not RESTful. I suppose we could call it show or something. But by default, we use put requests for all GraphQL queries, so that they're more secure. And basically, I don't think I have to go line by line through this. Basically, what it's doing is it's just taking the params that you send. So there's a query, that's the text that we've been looking at, and it feeds it to the schema and gives you and calls execute with all the variables, and then gives you the result. So yeah, this is basically just the glue to pass it off to the GraphQL schema. And then this is the first part of GraphQL that we define. So this is like the entry point into all queries in your GraphQL type system. So you have one branch for mutations, which are types that make changes to your system. And you have one branch for queries, which are things that don't make changes and they just return information to you. So we'll follow the queries to the query type. And then right here, we've only defined one query type for this example. And every connection is defined as a field. So this is the query type, and it has one field defined, and that's a list of to-dos. So we can query the query type and then ask for the to-do list on it, and then GraphQL knows from this to match it up to the to-do list type, and then it'll go to the to-do list type to figure out how to resolve that piece of information. So for to-do lists, or for every field in Ruby, if you don't pass other options, the first thing it'll do is it'll look for a method of the same name on your type. So to-do lists, the method matches the field, and so it will use that to look for how to resolve for the to-do lists. So we're going to take the context, which is just information that's to all types, and pull the current user off of that, and then get their to-do lists. So getting the current user's to-do list, which is pretty normal, and then yeah, we can limit that optionally with an argument, or we can leave it blank. And so once we fetch the to-do lists, then the way we tell GraphQL how to turn that into JSON, again, is we name a number of fields, the ID, the title, and the to-dos. And these are all optional fields, as we saw. You can choose to query any of these fields or not. If you were just showing a list of all your lists, then you could just go through and query all the titles and not have to query all the to-dos. But you could define this once and use it multiple ways on the front end. So from there, we can traverse another layer into our to-dos. This is our second layer of business logic. And then the to-dos are the terminus of this current example, where each of the fields, they resolve by querying the field of the same name on the object. So, in the Ruby app, I have a to-do model that has an ID and a name and a complete. And back here in to-dos, GraphQL by default, the to-dos field on the to-do list, and that's how it retrieved them from the database. And then each one of those then gets passed to a to-do type, and then it uses that to define each field. We give it information about the type, whether it's the ID type, which is a special type that we've defined, or also the built-in Ruby types like string and Boolean. So that's basically how you can set up a GraphQL API in Ruby. The beauty of it is that you can define your types once, and then you can pick, you can set up all your entry points, all your different queries, and the associations from them. And then once they're defined, you can just keep reusing them for different queries, only querying what you need for each particular application. So to go back to the original example we started with, we're querying to-do lists. This is the GraphQL query. So we query to-do lists with the title attribute, which is the field we saw, and then we'll get the to-dos off of it. And for to-dos, they are another type. So you also have to specify which fields off of the to-do objects you want, and we want the name and complete. And then we get the JSON back. And that's basically all the setup you need. So the other big part of it is mutations. And they work basically the same way. You write just a different type of query. You start it with mutation. That's the mutation branch that we saw in the GraphQL schema. And this mutation I've called to-do list create. And it just takes one argument, the title. And so you pass a title to to-do list create. And then you specify the types you're expecting back. So best practice is to expect back an error object or an array of errors. And then if it's successful, then you get back the to-do list with ID and title. So that way, both your client code and your server code knows what types to expect. If there are any mistakes, they are caught prior to getting deployed into production. So here's the mutation type. This is like the catch-all for all mutations that you want to create. So we just have one example here, but every change that you want to represent in your business logic, you put in here. And generally the best practice is to create a different mutation for every atomic change that you want to make. So like say in one form, you just update the user email and password or something like that. Make that one mutation and then make another mutation for updating your profile information. It just makes it more contained and much more easy to reason about. So you just define the to-do list create, which is basically, it's kind of the equivalent of an endpoint from our REST days. You know, that's not right, but there's a way you can think of it. And then you just define a mutation object to hook it up to. So this is basically the same as one of the other object types. Should I switch out? Thanks. The only difference here is the mutation takes an argument. So it takes the title that we saw from before, and then it defines the fields that it will return back, either the errors or the to-do list. And the errors we define as null false because we're always going to send back at least an empty array of errors. And then the to-do list, it can be nullable because if we fail, we have no to-do list to send back. And then every one of these just defines a resolve method, and that's how it resolves what the mutation does. So it takes the object, arguments, and the context. And you can get the current user off the context, and then use your typical Rails sugar to create to-do lists for your current user. And if that succeeds, then you send back an empty array of errors and the to-do list. And if it fails, then you send back some error messages in an array on errors and no to-do list. And because you've defined those fields, errors, and to-do list, GraphQL knows what to do with the object that you are returning from the resolve, and it hooks that all up together and knows which types to expect. So if you return the wrong type, it'll yell at you. Yeah, so that's mutations, just a small variation on the query type that we already went over. And then practically speaking, you know, authentication and authorization, that's another, it's another subject that kind of helps me understand, like it's another familiar, we're all familiar with authentication and authorization in like a RESTful world. So I think it's a helpful point of comparison to take a look at authentication here in GraphQL. And it's pretty easy. So here's a little bit of JavaScript. This is what the mutation definition would look like in React. And you're defining a mutation that you're going to call later. And it takes two types, or two variables, an email of type string. It's non-nullable, or basically required. And it takes a password. And then you pass it to session create, and it will return to you a session token. And you define this once and store it in a constant in code, and then later when you want to execute it, you pass it along with a variables object, and the email and password variables will be inserted for you. Yeah, so sign-in is just another mutation. It's just like the mutation that we saw defined on the client side. Here it is in Ruby. It's really similar to the mutation that we just went over. It takes an email and a password as the two arguments, and then it passes back an errors field and a session token if it's successful. Yeah, so I mean, it's like any other mutation, and it's pretty simple to implement. That you would only do once. Authorization, though, it works more or less like it would in a controller. So if we go back to the queries here, and we take a look at our to-do lists, the to-do lists query in this case assumes that there's a signed-in user. And so in order to, you know, scope the to-do lists to the current user, all you have to do is take the context, current user, and if we go back Hmm. Go to the controller. Right here, you can see you can pass in this controller whatever variables you want to the context. So we're passing the current user, but any other variables that are relevant to authorization or other things that you want available to all of your types as they resolve, you can pass to context, and they will be available in the context object. So yeah, once you look into it, that's pretty straightforward, I think. And the other big startup question I always have is, okay, how do we test it? There's a lot of magic going on, in the GraphQL world. How do we isolate the code that we're responsible for from the code that GraphQL is responsible for, and not test a lot of GraphQL functionality when we don't need to, and slow down our tests and all that stuff? So the good news is that's pretty easy. So first example here is kind of like a naive approach, or not a naive approach, but like integration-ish type test, where you're actually, if you look on the, right at the bottom of the left side here, so this, this, what we're actually doing is we're taking the GraphQL engine and actually executing the query string just like we would in the controller. We're passing it a context and variables, and it will combine that with the query string where it has a to-do list, and it accepts a limit here, and then that passes that to the to-do list query, and then it fetches the ID and the title and the to-dos like we're familiar with. And then we can define our expected response in Ruby objects or hashes and arrays, and then just write the expectation at the bottom. So this is good to make sure that you have everything configured correctly. The GraphQL engine is working correctly. You can run queries, but you're not going to want to do this for every test because you're actually using GraphQL in the engine, and it's going to slow things down, and you're testing things that you don't need to. So one technique you can use to separate out your functionality from your GraphQL types is just to use plain Ruby. One thing you do is decorators. So we saw how GraphQL, the types will automatically call the method of the same name as the field. So say we have this new field called icon from title, where we're doing that thing where we do a little bit of natural language processing and figure out like the icon that best matches the title that you've given your to-do list. So this is a little bit of complicated functionality that we want to test in isolation, and we don't want to test it alongside the GraphQL engine. So we just delegate that to a decorator, and then we instantiate the decorator and cache it, and then we can put all of our semi-complex functionality in the decorator. And then, you've probably seen this before. You can test the decorator in isolation, and you don't have to do anything with GraphQL. You have confidence that your complex functionality is running, and no mixing of concerns with your tests. So that's all I have. Are there any questions?
How do you document GraphQL API? Is there some? How do you document GraphQL API? Is there something like Swagger for GraphQL?
Yeah, there is. It's cool. It's called GraphQL, and it works with. Yeah, it ships by default to with GraphQL Ruby, and then let's see, GitHub. Yeah, GitHub has a really good example of it. So they call it their Explorer, but this ships with GraphQL Ruby. It runs by default. Oh, I'm not signed in. Yeah, so I won't force Brian to sign in, but maybe I can. It wants full access. Authorize. Go, go, go. What? Okay, there we go. Password. Give me your password. Shout it out. Thanks. Thank you for sacrificing for the good of the group. Uh-oh. All right. See if we can increase the size on this. Okay, cool. All right, so this is running against their live production database. And yeah, so this is the API Explorer. And you can just start typing in here, and you know, it'll autocomplete for you. So email is employee. What else can we find out about Brian? Yeah, so you can see all the attributes that are available on the current object. You can query other objects and then nest this query further and further. And then if you just want to click through the Explorer, you can take a look at all the type definitions. So let's dive into the queries. We can see every type of query that GitHub has defined. So they have a search query, okay, and that returns a search result item connection, and here are the arguments that it takes, and then if we get that back, here are the fields that we can query on it. So you can dive into it and learn a ton about it. And everything about this is auto-generated except for these descriptions right here. So this is an optional field on the GraphQL Ruby implementation, but it's easy enough to add that just as you're defining fields when you're developing the thing. And then here it is, you know, you can make it available for anybody to look through if it's a public API or it's there for your developers if it's an internal API. Yeah, thanks for asking that, so I could show that off.
Thank you.
Hi. I was sort of wondering, with your query object in Rails, I was looking the other day just to see, like, when you start adding like something for every table you have that you want to access, do you keep it in one query file, or did you start breaking out into like multiple like classes and inheriting them? I didn't see any like obvious ways on online. I wasn't sure what you came up with that.
Yeah, so I implemented GraphQL and then left my job and left the other developers to deal with it. Don't worry, I trained them, so they're all very comfortable with it. But I didn't get a chance to scale it personally, so I don't have personal experience, but I've read that basically there's an easy way to define a whole bunch of query types, basically one for every domain object in your business domain, roughly speaking. And then there's a pretty easy way to just splat them on the main query object. Okay. Yeah, so that's one option if you don't want to like nest queries under like subqueries under subqueries. So
okay.
That's what I've seen.
Okay, thanks.
I have two questions actually. Does Ruby support Playground for the GraphQL?
Mm-hmm. Yeah, it ships with GraphQL.
So
which is this thing that,
yeah,
that we're
playground.
looking at.
Okay, it supports the playground, right? Well, for the GraphQL.
Yep.
And I noticed like you're not using the active record anywhere. So what happens there?
Oh, like specifically with using active record versus other ORMs or?
Somewhere like you mentioned context, and context has a current user, and the current user has a to-do list, blah blah. It goes on it.
Yeah.
So instead of like action cable, you are just using the context through that way. So where exactly pulls that action record?
Yeah, so context is a GraphQL thing. So you pass in context to the execute call, and then the context is available across all your types, so you don't have to pass it down layer after layer after layer. So we passed in the current user there. So if we take a look at the controller again, yeah. So right here, this is where we pass in the context, and the context comes from, this is just a hash that we created, and I'm pretending here that you're using, Devise or any of the other auth systems, and it provides current user to you, and then you basically just pass it to the execute call, and then your current user is available to all of your types in all of the resolve methods. So you can use that to scope whatever your query is. And it doesn't have to be active record. You can use whatever ORM you want or nothing. This isn't dependent on Rails at all. I'm just using that because it's a common use case. That's what I used too.
So I just started at a new job, and I had been previously playing with GraphQL, and the new place uses JSON API. What would you say, why would you use one over the other? I don't know if you're familiar with JSON API, but I think a lot of the benefits of GraphQL you get from JSON API.
Well, I'm not familiar with JSON API. Is it similar where you define types and then you can reuse the types? And
the big benefits I see is that it has sparse fields, just you ask for what you want, and you get it back. And the other big benefit is it automatically provides the Rails implementation, the Ruby implementation has side includes. So you basically say give me the author and give me all the posts. So you just get that back automatically. I was wondering, and I actually been researching a little bit, so I was wondering why one person uses GraphQL versus JSON API. They seem very similar. The other question I was going to ask actually about GraphQL specifically is that do people run into N+1 issues often? Because I would imagine that you're basically having somebody arbitrarily provide what they want at runtime, and then querying what they want at runtime can probably be difficult. I mean, even when I know what I want, sometimes I get N+1 issues, performance issues. Do you run into that with GraphQL?
Yeah, absolutely you can. But I think it's similar to the problems you would run into with a REST API. So even though the user has a lot more freedom to query what they want, from their point of view, you still have to write each edge, each association, each field. And so, I mean, the usual advice is write it the naive way first. Don't over-optimize first pass. And then, as you get more usage, and you run into problems, you can do the same things you would do in a controller for side includes, any other optimization, dropping down a SQL, whatever you want.
But I would imagine you'd have to parse what they're querying for and be okay, they're querying for users with posts. I better include posts, right? You kind of have to parse what the query is because you don't want to include posts if you don't need it.
Yeah. Let's see. So right here, here we have the to-do list, and yeah, actually, okay. So this example isn't going to work out, but Yeah, I mean, suffice it to say that I think you can basically, whenever you define an association between two types, you can define the same includes, and you can include them once by sort of introspecting into what the query shape is like. Yeah.
Cool. Thank you.
Hey, thanks for the talk. I have a lot of questions, but I'm going to try to limit them down to two. I wonder if you could talk more about your decision to use put requests for all your GraphQL routes. And as someone who's going through the same thing that you were, what are some of the like unknown unknowns that I wouldn't read in the GraphQL documentation?
That's a good question. Okay, so for the put requests, it's put by default so that you can avoid session hacking. You know, the protection is on by default in Rails, and but we actually ended up splitting out our queries versus our mutations, and we created two controller endpoints. I didn't want to get into it because you might not run into it, but yeah, basically we were finding that in order to get the authenticity token, we'd have to have a prior request to get a fresh authenticity token. And when you first load the page, you can't guarantee that. That could be their first contact with the app that day. And so the better user experience was to not require the authenticity token for queries when you can't do any damage. Or at least you can't mutate things. And then in the response to that, we send back the authenticity token as you normally would, and then it's available to the user to be sent back for a subsequent mutation that we continue to run through puts. So yeah, that's how we ended up splitting it out. But you know, depending on what you use for different security measures and what you feel comfortable with, you could do it a lot of different ways. You don't even have to run GraphQL over HTTP. I know I mentioned that. So practically speaking, that doesn't do you a lot of good when you're running a web app or a native app, but that's just another option. So, you know, GraphQL is layered on top, and the security issues with HTTP requests are the same as they always were, basically. Yeah, and good security for API design still applies. And then the unknown unknowns. I'm trying to think if there were, I mean, I haven't run into anything that I could flag as something that you should really watch out for. You know, it's been all kind of greenfield for me so far, so I'm sure there is something once you get really large and complex, but yeah, I haven't run into that yet, honestly, so I'll get back to you.
One unknown that we found was that when you query and you say, like, let's say I just want the to-do list has that. The to-do list has like that complex, the natural language processing thing. So one thing that we ran into was that if you didn't explicitly ask for that, it would still run that code. I don't know. We were doing it with Elixir, not Ruby, so it might be the Elixir library, not the Ruby library. But just like making sure like explicitly, you can like explicitly check which fields are coming in and then say like, okay, if these fields are coming in, like get these attributes, or if these fields are coming in, get those attributes. So you can do something like, for us, one thing made an external request if you included this field. So it was, you know, if you don't have this field, then you don't need to make this expensive external request.
Yeah, that's a really important part of implementation. We didn't run into that in the Ruby implementation, so I don't know if we got lucky or what.
Sorry, I only have one question. So you mentioned Greenfield, but if you had a pretty massive app already that was RESTful, and let's say, hypothetically, your front-end developers were like, GraphQL is amazing, we have to switch to GraphQL. Do you really think it's actually worth the effort? Are there enough benefits to actually switch a legacy app over to GraphQL, or is RESTful pretty much good enough for the majority of apps, and it's just a new shiny thing?
Well, I wouldn't say it's just a new shiny thing. I think there are pretty big efficiency benefits for what we saw over writing REST and sort of doing a lot of custom coding on the server side for each new endpoint. I think it reduces the effort of expanding out your API once you start defining some types and gives you, at least compared to the way we used to be writing APIs, a lot more confidence and ability to introspect into what the API was like. So I really do like the benefits of GraphQL, but I would definitely not make a blanket recommendation to rewrite a legacy REST API. A lot of the benefits accrue when you spend less time writing in the first place, and you already have an API, so you're going to spend a lot of effort rewriting it for no clear benefit. I think the thing that I would recommend would be if you were expanding into a new endpoint and maybe a slightly different service that's a little separated from the rest of your API, give GraphQL a try. And if you like the benefits, then you can make future APIs GraphQL and slowly convert over. That strategy tends to work better, in my experience, than any sort of rewrite ever. So.
I actually have a question.
Go ahead, Spencer.
What role, if any, do you see in traditional HTTP status codes? Because there are a lot of layers across your application to your client that might rely on either caching based off status codes of unauthorized for a one or a redirect or stuff like that I don't really see, at least in your examples. They mainly rely on this error array that each layer would have to be updated to kind of respond to. So do you see any pitfalls that you might face just by relying on this error array, or is there some way to kind of incorporate these pretty good standards that we've set for HTTP status codes?
Yeah, you make a good point, and I think there definitely is a way to set the same status codes that you would for a typical REST API. That's not something that we did in my implementation, but I don't see anything that would prevent you from taking a look at the response that you're sending back out and setting a different status code in the controller if you want to integrate with a caching layer, or you just want to communicate with the browser or anything like that. That would be another layer that you'd have to navigate, and that wouldn't be working by default the way I have it set up here. One thing that I will say is kind of nice, at least not on the caching and infrastructure level, but on the user experience level, is it's really nice to have to bundle all of your error types into one channel. So you're probably familiar with the problem where you have different layers of validations on the client side, on the server side, and then the validations you explicitly write on the server side, and then actual errors. And you have to write error handling code on your client for all three different types of unexpected events. And this doesn't do away with the potential for, you know, a 500 error. But, you know, basically because all your communication happens at the application level, you can use your client application to handle all your error states in a coherent way. So I actually like the way that you respond to all errors with application code rather than status code, at least on a user experience level. Yeah.
Great, thank you. Yeah, round of applause for our speakers. I think we have 20 more minutes left of the meetup, so feel free to mingle. EXO Group is also looking for engineers, so if you guys want to stop by, talk to myself or Brendan, if you have any more additional questions about GraphQL, feel free. Yeah, enjoy the rest of the night.